Hello there and welcome to the Sleepy Cosmos channel. Tonight we are traveling beyond the atmosphere, beyond the reach of weather and noise and the ordinary weight of days. We are going somewhere vast and very still. We are going into the solar system. Not the solar system of textbooks and diagrams, though those have their own quiet beauty. We are going to the solar system as it feels when you close your eyes and let your imagination drift slowly outward, past the clouds, past the satellites, past the moon, and into the deep and stunning dark that holds our little family of worlds. These 8 planets and their dozens of moons, their rings and their storms and their ancient craters, have been turning quietly around our sun for more than 4 billion years, long before there were eyes to see them, long before there were names to give them, long before anyone lay down at the end of a day and looked up and wondered what those points of light really were. Tonight, you will travel to each of them in turn. You will feel the warmth of Mercury on the side facing the sun and the cold on the side that faces away. You will drift through the yellow clouds of Venus and ride the slow blue currents of Neptune. You will stand on the rust-colored plains of Mars and watch a moon rise that moves so fast it crosses the whole sky before sleep can take you. This is not a journey that requires anything of you. You do not need to stay awake for it. You do not need to remember the distances or the temperatures or the names of the craters. This is a journey you take by letting go, by breathing slowly, by allowing the enormous quiet of space to settle over you the way a heavy blanket settles over a cold evening. If you enjoy these gentle journeys through the cosmos and through history, I want to invite you to like this video, subscribe to the channel, or leave a thought in the comments below. It helps other tired people find their way here too, one sleepy soul at a time. But for now, simply settle in. Let your body feel the weight of the bed or the chair or the floor beneath you. Let your breathing slow down just a little and allow your mind to begin to wander. We will start very gently, very close to home, and then we will drift outward together into the beautiful, enormous, endlessly patient dark. Let's begin. The sun is the reason any of this exists. Before the planets, before the moons, before the rings of Saturn and the storms of Jupiter and the quiet ice at the edge of everything, there was a cloud. A slow, enormous cloud of gas and dust drifting through the early galaxy the way fog drifts through a valley on a cool morning. That cloud was mostly hydrogen. It was patient in the way that only things without minds can be patient. Perfectly, completely, unhurriedly patient. And then something disturbed it. Perhaps a nearby star ended its life in a great explosion. Perhaps the gentle pull of the galaxy's own rotation nudged the cloud over centuries until one region grew just slightly denser than the rest. That extra density pulled more gas toward it. More gas meant more gravity. More gravity meant more gas. And slowly, over millions of years, at the center of this collapse, something began to heat up. What started as a cold and featureless cloud became a swirling disk. At the center of that disk, pressure and temperature climbed until a threshold was crossed and hydrogen atoms began to fuse together. Light and heat poured outward in all directions. The sun was born. And around it, in the flat disk of leftover material that had not fallen inward, Smaller clumps of matter began to gather themselves together. They collided, they stuck, they grew. Some grew large enough to pull themselves into spheres under their own gravity. These were the planets. They are, in a very real sense, the sun's children, made from the same cloud, shaped by the same process, held in place by the same ancient bond. Tonight, you are going to visit each of them. The solar system is bigger than most people can comfortably imagine. When we draw diagrams of the planets in books, we almost always cheat. We have to. If we drew the planets at their actual sizes relative to the distances between them, most of the page would be empty. The sun would be a tiny dot on one edge. Earth would be invisible. Neptune would be somewhere off the page entirely. The real solar system is made mostly of nothing. Vast expanses of absolute emptiness, crossed occasionally by light and radiation and the slow drift of comets and dust. That emptiness is not frightening. It is restful. It is the kind of space that absorbs sound, absorbs urgency, absorbs the feeling that anything needs to happen right now. Out there, in the dark between worlds, there is no traffic, there are no notifications, there is no particular time. There is only the slow, patient movement of gravity doing its ancient work. And there is the light of the sun diminishing with distance, becoming something you could cover with your thumbnail held up at arm's length if you were standing out near Neptune, looking back. That light still reaches Neptune, though, faint but real. A connection stretching across billions of kilometers of silence. That connection is what holds the solar system together. Not walls, not fences, but the invisible architecture of gravity, shaping every orbit, every season, every tide, every night. Space travel, real space travel, is slow. The fastest spacecraft humanity has ever launched took decades to reach the outer planets. A journey to Neptune by rocket would take years. But in the mind, the journey takes only as long as you're breathing. And so tonight, we move through the solar system at the speed of dreams. You might feel yourself becoming lighter as we lift away from the Earth. The weight you carry during the day, the weight of decisions and worries and things left undone, can stay behind. None of that weight is permitted in orbit. Out here, everything floats. Thoughts become slower and gentler. The body begins to relax in ways it never quite manages during a busy day. You can feel it already, perhaps a softening in the shoulders, a loosening in the jaw, a heaviness in the eyelids that is not unpleasant, not the heaviness of exhaustion, but the heaviness of permission. Permission to stop. Permission to drift. Permission to let the solar system carry you tonight instead of the other way around. Mercury is the innermost planet, and it keeps a secret. You might expect the planet closest to the sun to be the hottest in the solar system, and Mercury is certainly hot enough. On its day side, the surface temperature climbs past 400 degrees Celsius, hot enough to melt lead. Hot enough that if you stood there without protection, the very rock would glow faintly in the infrared. But Mercury's secret is its night. Because Mercury has almost no atmosphere to trap the sun's heat, the moment a patch of ground rotates away from the light, the temperature plummets. On the night side of Mercury, the temperature drops to nearly 200 degrees below zero in a matter of hours. The same planet that roasts under direct sunlight freezes in the dark. This extreme duality makes Mercury one of the strangest places in the solar system, a world of absolute contrasts, absolute heat and absolute cold separated only by the slow turning of a rocky globe. Mercury is covered in craters. Billions of years of impacts have left their marks on the surface in overlapping circles, some ancient and worn smooth by later bombardments, others crisp and sharp-edged, where more recent collisions punched clean holes into the crust. The largest basin on Mercury is so big you could fit a small country inside it. It was formed long ago when something enormous struck the young planet with enough force to ripple the crust on the opposite side of the world. Imagine standing at the center of that basin, looking up at a sky without air, without clouds, without color. Just black sky and the Milky Way blazing overhead in a silence so complete you would hear your own heartbeat more clearly than you ever have. And there, taking up a large portion of the sky, the sun, not warm and friendly the way it looks from Earth, here it is 3 times larger. Brilliant and imposing and ancient, you watch it move. Slowly, very slowly. Mercury's days are longer than its years. The planet orbits the sun faster than it rotates. So sunrise on Mercury is a rare and unhurried event. And when the sun rises, it sometimes appears to move backward briefly before resuming its usual path. A strange and silent waltz between orbit and rotation that has been playing out for billions of years with nobody watching. Until tonight. Venus is the planet that almost became Earth, or so some scientists believe, long ago when the solar system was young. Venus may have had liquid water on its surface. It may have had shores and rivers, and perhaps even the conditions that allow certain kinds of chemistry to become complicated, to become interesting. But something went wrong. The sun grew slightly warmer over billions of years. Or perhaps the volcanic activity on Venus released too much carbon dioxide into the young atmosphere. Either way, a process called the runaway greenhouse effect took hold. Heat came in from the sun and could not escape. Temperatures rose. Oceans, if there were oceans, evaporated. The water vapor made the greenhouse effect stronger. Temperatures rose more. And slowly, over geological time, Venus transformed from a world that might have been welcoming into the most hostile planet in the solar system. Tonight, we do not go down to the surface of Venus. We stay high in its atmosphere, in the upper cloud layers, about 50 to 60 kilometers above the ground. At this altitude, the temperature and pressure are almost Earth-like, and there are clouds, vast, swirling, yellow and cream colored clouds of sulfuric acid that would dissolve your hand if you reached into them. But from a distance, and if you allow your mind to soften the edges a little, they are beautiful. They roll and billow in the upper winds. The winds here are faster than any hurricane on Earth, circling the whole planet in just 4 days. But in our dream, the clouds move slowly. They drift the way clouds drift on a summer afternoon, heavy and lazy and full of quiet. The light here is different from Earth. Everything is tinted amber. The sky above is dark blue. The clouds below are yellow-white and lit from beneath by the dull orange of the surface heat. It is like floating in the last hour before sunset, stretched out endlessly in every direction. You can feel yourself relaxing into it. The amber light. The soft, distant sound of wind. the sense that nothing is required of you here except to drift. Earth, seen from space, is small and extraordinary. If you have ever seen the photograph taken by the Voyager spacecraft as it left the solar system, the one where Earth appears as a tiny pale blue dot suspended in a ray of scattered sunlight, you may have felt something that was difficult to put into words, something between smallness and tenderness. The Earth seen from that distance, from nearly 6 billion kilometers away, occupies less than a single pixel of the image, and yet it holds every person you have ever known, every person who has ever lived, every story that has ever been told, every love and every loss, every ocean and mountain and field, everything that has ever been called home fits into that invisible speck. From closer in, from the distance of the moon, for example, Earth becomes recognizable. You can see the blues and greens. You can see the white swirls of weather systems moving across the surface. You can see the dark patches of ocean at night, dotted with the faint lights of cities. From orbit, you can begin to make out coastlines, the shapes of continents, the silver threads of rivers. Right now, as you listen to this, the Earth is turning. It turns slowly enough that you cannot feel it, even though the surface at the equator is moving at more than 1,000 miles per hour. The stars above you are moving across the sky, not because they are moving, but because you are. Very slowly, very gently, spinning in the dark with everyone else who is alive tonight, all turning together under the same canopy of stars. And on the night side of the planet, which is where you are right now, millions of people are doing the same thing you are doing. Lying still, breathing slowly, letting the day go. The Earth tonight is full of quiet breathing, full of the soft and patient work of rest. You are part of that. You always have been. The moon pulls the ocean toward it. Tonight, somewhere on the coast, a tide is rising. The water is moving, not because of wind, but because the moon is overhead and its gravity is drawing the ocean gently in its direction. The same moon that lights the night, that has been the subject of songs and poems and fears and navigational charts for as long as people have had language, is also doing this quiet, invisible work of pulling the sea. The moon formed in one of the most violent events in the early solar system. A planet roughly the size of Mars collided with the young Earth. The impact was incomprehensible in scale. It melted the outer layers of both worlds and threw enormous quantities of debris into orbit. That debris slowly coalesced, gathered itself into a sphere, and became the moon. And from the very beginning, it has been slowly moving away from us, just a few centimeters per year. Imperceptible, but over billions of years it adds up. When the moon first formed, it was much closer. It would have dominated the sky. Ancient tides would have been enormous. But now it has drifted to a comfortable distance, and it has slowed the Earth's rotation and stabilized our axial tilt, making our seasons more predictable and our climate more stable. In a quiet and mathematical way, the moon has been protecting us for billions of years, even as it slowly drifts away, even as it does its silent nightly work of pulling the tide and lighting the dark and keeping us company as we sleep. Mars is the planet that has captured human imagination for centuries. Long before anyone knew what it actually was, people noticed that one of the wandering lights in the night sky was reddish, different from the others. Ancient cultures named it after war and fire and blood. The Romans gave it the name it carries today, and for thousands of years, people projected their fears and hopes onto that little red point of light, not knowing that it was a place, a real place, with weather and geology and mornings and evenings, a place where, if you stood on the surface, you would see a sky the color of butterscotch at midday, and a deep dusty blue at the horizon during sunrise and sunset, a place where sometimes, for weeks at a time, a planet-wide dust storm rolls in and turns the whole world amber and silent and strange. We drift down through the thin Martian atmosphere. It is mostly carbon dioxide. It is less than 1% as dense as the air on Earth, so thin that if you took a deep breath, you would take in almost nothing. But we do not need to breathe here. We are weightless travelers carried by imagination, and we can feel the cold without being harmed by it. The temperature on Mars on a summer afternoon at the equator might reach 0 degrees Celsius for a few hours, but tonight we are in the evening, and the temperature is dropping quickly. By midnight, it will be 80 degrees below zero. We stand on a wide, flat plain covered in reddish-orange dust. The dust is fine, finer than talcum powder, and it has been ground down by billions of years of freeze and thaw and wind. The sky above us is enormous. Mars has no large moon to catch our eye the way ours does. Instead, there are two small moons, Phobos and Deimos. Phobos rises in the west and sets in the east, crossing the sky in just a few hours. It moves so fast you can almost watch it travel if you are patient and still. The silence on Mars is total. There is no bird song. There is no wind tonight. There are no waves, no traffic, no voices, no distant music from a neighbor's window. There is only the faint groan of the ground contracting in the cold. And above that, nothing, a silence so complete it becomes its own kind of presence. You stand in it and you feel your own thoughts becoming quieter in response, as though the Martian silence is setting an example and your mind is following. The great volcano Olympus Mons is on the other side of the planet tonight. The largest volcano in the solar system, so wide that if you stood at its base, you could not see the summit, so tall that it rises above most of the planet's thin atmosphere. A sleeping giant that last erupted millions of years ago and has been quiet ever since. Even volcanoes, eventually, sleep now. If you are still with us, this is a good moment to simply breathe. In through the nose, slowly filling the chest, and out through the mouth, slowly letting the shoulders drop just a little further with each exhale. The Martian plains are dark now. The butterscotch sky has gone deep blue-black, and the stars are coming out. And this is where I want to pause and say something to you. If this kind of journey helps you find rest, if it helps you drift away from the day's noise and into something quieter, then please consider subscribing to this channel. There are more journeys here, through oceans and forests and ancient cities and the far reaches of the cosmos, each one made to help you rest, each one made for evenings like this one. You can subscribe by pressing the button below, and you will be notified whenever a new journey is ready for you. There is no pressure. This journey will continue either way, but if you find comfort here, I would love to keep making these for you. Now back to the stars. Between Mars and Jupiter, there is a belt, a wide ring of rocky objects that orbit the Sun in the gap between the two planets. These are the asteroids, millions of them, possibly billions, counting the small ones. They range in size from tiny pebbles to objects hundreds of kilometers across. The largest, Ceres, is so big that it qualifies as a dwarf planet. People sometimes imagine the asteroid belt as a dangerous, crowded obstacle course, the way it looks in movies, where spacecraft have to dodge between enormous tumbling rocks. The reality is gentler than that. The belt is mostly empty. The rocks are spread across such a vast volume of space that if you flew through the belt in a spacecraft, you would probably never come close to hitting one. You would float through in perfect safety, and you might not even see an asteroid unless you went looking. We drift through the asteroid belt slowly. Around us, in the dark, rocks turn in their slow orbits. Some are made of stone, some of metal. A few are rich in carbon and water-bearing minerals, black and crumbling and ancient, almost as old as the solar system itself. They catch the sun's light on their nearest faces and leave their far sides in shadow. Many of them have craters from long ago collisions. A few have small companion rocks orbiting them, tiny moons around boulders, gravity working even at small scales, with the same patient mathematics that applies to planets. We pass among them without disturbing them. They barely notice us. They have been turning for 4.5 billion years, and they will go on turning long after we are gone. There is something deeply restful about that kind of permanence. The asteroids do not hurry. They do not worry. They simply orbit, round and round the sun in their quiet ancient paths, following the curve of gravity as naturally and effortlessly as breathing. Jupiter is the largest planet in the solar system, and it has been playing the role of protector for billions of years. Its enormous gravity has pulled comets and asteroids out of dangerous trajectories that might otherwise have sent them toward the inner planets, toward us. Without Jupiter, Earth might have been struck far more often by large impacts. Life might have been interrupted or ended several times over. The giant planet, so far from Earth, so alien in its composition and scale, has been quietly keeping the inner solar system safer simply by existing, by being as massive as it is, by doing what gravity does. Jupiter is made mostly of hydrogen and helium. It has no solid surface. If you tried to land on it, you would sink through layers of increasingly dense atmosphere until the pressure became unimaginable. The boundary between atmosphere and interior is not a surface at all. It is just a gradual thickening, an ocean of metallic hydrogen so dense that electricity flows through it the way it flows through copper, and at the very center there may be a dense core of rock and ice, but we are not certain. Jupiter holds its interior as a secret kept under millions of atmospheres of pressure. What we can see of Jupiter is the atmosphere, and the atmosphere of Jupiter is one of the most beautiful and violent things in the solar system. The planet's rapid rotation, a full day on Jupiter, lasts only about 10 hours, stretches the cloud bands into long horizontal stripes, creams and tans and tawny browns and whites that wrap around the whole planet in parallel ribbons. Between the bands, where different cloud layers meet and shear against each other, storms form, turbulent cells of rising and falling gas that create oval shapes at the boundaries between belts. And then there is the Great Red Spot, a storm that has been observed continuously for at least 350 years, possibly much longer. A hurricane larger than the entire Earth, with winds reaching more than 400 kilometers per hour, that has been spinning steadily since before the telescope was invented. It is slowly shrinking. Scientists are not entirely sure why. Perhaps it will disappear in our lifetime, or perhaps it will persist for another century. Either way, it has outlasted empires and languages, and the lifetimes of every human who has ever lived. We float above the Great Red Spot at a safe and dreamlike distance. Below us, the clouds spiral slowly inward toward the eye of the storm. The colors shift from cream at the edges to a deeper terracotta at the center, where the atmosphere rises and cools and spreads outward at the top like smoke from an enormous slow chimney. There is no sound we can hear. In our dream, this storm has the quality of all great natural forces. Seen from far enough away, it looks peaceful. It looks like the turning of something inevitable, something that was always going to be this way. You can watch it turn and feel no urgency. It is not asking anything of you. It is simply doing what it has always done, turning slowly in the Jovian dark. Jupiter has 4 large moons that Galileo first observed 400 years ago. He watched them night after night and noticed they were moving. Not stars at all, but worlds, orbiting Jupiter the way planets orbit the sun. It was one of the first pieces of evidence that not everything in the universe revolves around Earth. Io is the most volcanic body in the solar system, pulled and kneaded by the competing gravitational forces of Jupiter and the other large moons until its interior stays molten and its surface erupts continuously. Europa is covered in a smooth shell of ice with an ocean of liquid water believed to exist beneath it, a dark, salt ocean warmed by tidal flexing, possibly containing more water than all of Earth's oceans combined. Some scientists believe it may be the most likely place in the solar system, after Earth, to harbor life. Ganymede is larger than the planet Mercury. Callisto is ancient and cratered, its surface almost unchanged for billions of years, one of the oldest preserved surfaces in the solar system. 4 worlds, each one different, each one remarkable, each one turning quietly around Jupiter in the outer dark. We leave them behind slowly, gently moving outward. Saturn is a wonder. There is no other word for it. When you see the planet for the first time through even a small telescope, the rings seem impossible. They seem like something you painted there, something too perfect to be real. But they are real, enormously, spectacularly real. The rings of Saturn are made of billions of pieces of ice and rock, ranging in size from tiny grains to chunks as large as houses. They stretch more than 200,000 kilometers from the inner edge to the outer edge, far enough that they would reach more than halfway from Earth to the Moon, yet they are astonishingly thin. In most places, the rings are only about 10 meters thick. 10 meters, less than the height of a 3-story building, an enormous glittering disk spread across hundreds of thousands of kilometers, and yet thinner in proportion than a piece of paper. We drift down through the rings. Around us, ice particles catch the sunlight and scatter it in every direction. The light here is different, softer, more diffuse. as though the sun's rays have been broken into a million pieces and spread evenly through the space around us. The ring plane feels almost like snow, quiet and clean and full of light that seems to come from everywhere at once. But particles move with us, or we move with them, orbiting Saturn in our own lazy ellipse. If you reached out your hand in this dream, you might touch a slow-moving chunk of ice the size of a car, white and slightly blue, and drifting past at almost the same speed you are traveling, so that relative to you, it appears nearly motionless. You could push it gently, and it would continue on its orbit, slightly perturbed, traveling a new path that will never quite repeat the old one. Even small things change the path of other things. Even gentle touches leave marks in the mathematics of orbit. Saturn has a moon called Titan. Titan is larger than the planet Mercury and is the only moon in the solar system with a thick atmosphere. That atmosphere is mostly nitrogen, like Earth's, but instead of water, Titan has lakes and rivers and seas of liquid methane and ethane, hydrocarbons pooling on the surface, evaporating, forming clouds, raining back down again in a slow cycle that mirrors our own water cycle, but is made of entirely different stuff. The Cassini spacecraft spent years orbiting Saturn and sent the Huygens probe down through Titan's orange haze to the surface in 2005. It was the most distant landing ever achieved at the time. The probe floated down through a sky the color of a deep winter sunset, amber and orange and brown, and settled on a surface covered in rounded pebbles of water ice, smoothed by ancient rivers of methane. It survived on the surface for about an hour and a quarter, sending back data across the billions of kilometers of empty space before the cold and the distance silenced it. That hour and a quarter is one of the most remarkable achievements in human exploration, and tonight, in our dream, we honor it by floating past Titan's orange clouds, looking down at a world that reigns from a different kind of sky. Saturn also has a moon called Enceladus, small and white and brilliant, its surface covered in fresh ice that reflects almost all the sunlight that reaches it, making it one of the most reflective objects in the solar system. And from the south pole of Enceladus, enormous geysers erupt continuously, shooting jets of water and ice hundreds of kilometers into space. This water comes from a liquid ocean beneath the moon's icy shell. The geysers are Enceladus venting to space, and some of that ejected material goes into orbit around Saturn and contributes to the outermost ring. The ocean beneath Enceladus contains hydrothermal vents on the seafloor, warm and chemically rich, similar to the vents on Earth's ocean floor, where entire ecosystems thrive without any sunlight at all. Some scientists consider Enceladus the most promising candidate for life in the solar system, more immediately accessible even than Europa. A tiny moon, barely 500 kilometers across, holding inside itself an ocean and perhaps more. We drift past in the quiet dark and listen to the silence where the geysers rise and fall and rise again into space. Uranus is the planet that decided to lie on its side, while all the other planets in the solar system rotate on axes that are roughly upright, tilted slightly like a spinning top that hasn't quite lost its momentum. Uranus rotates on an axis tilted nearly 90 degrees. It rolls around the sun like a ball rolling along the floor, rather than spinning like a top. We do not know exactly what caused this. Perhaps a large impact early in the solar system's history struck Uranus at just the right angle to knock it over. Perhaps it was a series of smaller impacts. Perhaps there was some other mechanism. The mystery is still open. But the effect is remarkable. During the course of Uranus's 84-year orbit around the Sun, each pole spends about 42 years in continuous sunlight and 42 years in continuous darkness. The seasons are extreme in a way that is difficult to imagine. An Antarctic winter stretched across decades, a polar summer that lasts longer than a human lifetime. From a distance, Uranus is blue, a pale, featureless, almost luminous blue that comes from methane in the upper atmosphere, absorbing red light and reflecting blue. It is a color unlike anything in Earth's sky, not the blue of our daytime or the blue of our twilight or the blue of our deep ocean, something cooler and more distant, something that belongs entirely to itself. We float beside it in the dark and take in that blue. We do not need to go closer. We do not need to understand all its chemistry or catalog its 27 known moons. We can simply rest here in the presence of this quiet, tilted world and let the color settle over us the way dusk settles over a long afternoon. Uranus is in no hurry. It takes 84 years to complete one orbit. Time here moves at a different rate than it does back home. Watching this blue planet from our quiet vantage, it is easy to let time do the same thing, to let it slow, to feel it stretch out and become less urgent, each breath taking longer, each thought arriving more softly. Before we reach Neptune, I want to pause with you here for just a moment. We are about halfway through our journey tonight, and I want to invite you to notice how your body feels right now. Notice your hands. They are resting somewhere and they are still. Your feet are probably still as well, heavy and warm, not needing to go anywhere. Your breathing has probably slowed since we began. That is good. That is what this journey is for. If you are listening to this channel for the first time tonight, I want you to know there are many more evenings like this one waiting for you here. More journeys through the cosmos and through history and through the quiet corners of the natural world. If you would like to find them, you can subscribe to this channel and they will be there whenever you need them. You can do it now, or you can simply continue resting. Either way, I am glad you are here. Now, let's continue outward, into the cold and the dark and the unexpected beauty at the edge of our solar system. Neptune is the last of the 8 planets. From Neptune, the Sun appears as a brilliant star, still the brightest object in the sky, but not the overwhelming disk of fire it appears as from Earth, just a very bright star among a very dense field of stars. At this distance, sunlight is about 900 times dimmer than it is on Earth, and yet it is still there. A point of light connecting Neptune to the rest of the solar system by a thread of ancient photons, each one having traveled for more than 4 hours before reaching this place. Neptune is a deep, vivid blue, deeper than Uranus, richer and more saturated, as though the planet is made of nothing but the idea of blue, compressed and intensified by pressure and cold. It is the most beautiful blue in the solar system, in my opinion, the kind of blue that makes you want to be very still and simply look. Neptune also has the fastest sustained winds in the solar system, not just a local storm like Jupiter's Great Red Spot, but continuous winds that circle the entire planet at speeds exceeding 2,000 kilometers per hour, winds faster than the speed of sound. And yet from our distance, Neptune appears serene. Those winds are invisible at this scale. The planet simply turns in the dark, wearing its deep blue like a cloak. Neptune has a large moon called Triton that orbits in the wrong direction. While nearly all large moons in the solar system orbit their planet in the same direction the planet rotates, Triton orbits Neptune backward. This tells us that Triton did not form here. It was captured. Long ago, Triton was a free-floating body in the outer solar system, perhaps a resident of the Kuiper Belt, the region of icy objects beyond Neptune, and through some gravitational chance encounter, it was captured by Neptune's gravity and dragged into orbit. Its original retrograde path was preserved, and now it orbits backward, slowly spiraling inward, and will eventually be torn apart by Neptune's gravity in about 3.5 billion years to form a new ring system. Time at this scale is patient beyond imagining. Triton itself is a frozen world, but it is not entirely quiet. The Voyager 2 spacecraft flew past Neptune in 1989 and discovered geysers on Triton's surface. Not water geysers like the ones on Enceladus, but nitrogen geysers, erupting from patches of surface ice that are warmed just barely by the distant sun, the pressure building until a crack forms and a jet of gas and dark material shoots several kilometers upward into the thin atmosphere. Winds then carry those plumes sideways, leaving dark streaks across the pink ice surface that Voyager photographed as it sped past at 30 kilometers per second. Those photographs of Triton's dark streaks are among the most remote images ever taken of a surface feature from close range. They come from a world so far from the sun that the surface temperature is about minus 235 degrees Celsius, among the coldest surfaces in the solar system. And even there, even in that profound cold, something moves, something erupts, something changes. Life, or something like its distant cousin, stirring even at the edge of everything. Beyond Neptune lies the Kuiper Belt, a broad donut-shaped region of icy objects extending from Neptune's orbit outward to about 50 times the Earth-Sun distance. Pluto lives here, small and beloved and cold, taking 248 years to complete a single orbit around the Sun. When Pluto was at its closest to the Sun within living memory, the New Horizons spacecraft flew past it in 2015 and revealed a world of startling complexity. Mountains of water ice as tall as the Rockies. A vast heart-shaped plain of nitrogen ice, slowly convecting in enormous cells, turning over on timescales of centuries. A thin atmosphere of nitrogen and methane that freezes and collapses onto the surface every time Pluto moves to the far end of its long elliptical orbit. A world that breathes on a timescale of centuries. And beyond the Kuiper Belt lies the Oort cloud, not a place you can point to, not a place we have ever visited or even photographed, but a theoretical region inferred from the paths of long-period comets extending perhaps a quarter of the way to the nearest star, a vast shell of icy bodies loosely bound to the sun by gravity, slowly responding to the gravitational tugs of passing stars and the galactic tide. Some of them, nudged out of their ancient orbits by these distant forces, begin a long fall inward toward the sun, a journey that takes tens of thousands of years, and when they arrive, They heat up, they develop tails of gas and dust that point away from the sun, and they become comets, blazing briefly through the inner solar system before swinging back out into the dark. Each comet is a piece of the original solar system, barely changed since the days when the sun itself was forming. They carry water and organic molecules, the building blocks of life. Some scientists believe that the comets and asteroids that struck the young Earth contributed some of the water in our oceans. Every ocean, every river, every glass of water you have ever drunk may contain molecules that traveled here from the outer solar system billions of years ago. The solar system, it turns out, is not a collection of separate worlds. It is a single connected system, exchanging material across vast distances over geological time. And now we have reached the edge. We float in the darkness beyond the Oort cloud and look back. We can see the sun from here, still just barely. A point of light slightly brighter than the brightest star. The planets are invisible at this distance. Even Jupiter is lost in the glare. The whole solar system, all 8 planets and their moons and the asteroid belt and the Kuiper belt and everything else, fits in a region of sky smaller than your thumbnail held at arm's length. All of it. Everything we have visited tonight, every world we have drifted past, fits into something you could cover with your thumbnail. And the distance to the nearest star system, Alpha Centauri, 4 light-years away, is still more than 4 times greater than the distance between us and the sun. The solar system is enormous, and the universe is incomprehensibly larger. We are, all of us, on a tiny world in a small solar system in the outer reaches of an ordinary galaxy among hundreds of billions of galaxies. And yet, here we are, alive, conscious, wondering. There is something about contemplating that scale that is not frightening if you approach it from the right angle, or rather if you approach it lying down in the dark, breathing slowly, at rest. The universe does not require anything of you. It is not waiting for you to be productive. It is not keeping score. It has been here for 13.8 billion years, and it will be here long after every monument humans have ever built has been dissolved by time. And in all of that, you have this moment, this breath, this heartbeat, this strange and brief and vivid experience of being alive on a small rocky world covered in ocean and atmosphere, held at a perfect distance from a middle-aged yellow star. That is not nothing. That is everything. We turn now and begin the long journey home. Neptune falls behind us, a blue pinpoint growing smaller. Uranus disappears into the dark. The sun grows brighter, slowly, as we pass through the outer solar system, through the region of the giant planets, past Saturn's rings catching the light, past Jupiter's cloud bands, past the asteroid belt with its slow and ancient tumbling rocks. The sun grows larger, and the inner solar system spreads out ahead of us. We pass Mars in the night, its reddish tint visible even from this distance. We pass the moon, bright and full tonight, turning its familiar face toward us as it has for billions of years. And there ahead is Earth, blue and green and white. Alive, the only world in the solar system where tonight lights are on, or someone is heating milk on a stove, or someone is reading by lamplight, or someone is putting a child to sleep, where you are lying still, breathing slowly, having traveled in your imagination to the edge of the solar system and back, and now returning to the place you started, the most extraordinary place in the known universe, your home. You are back now. Not that you ever really left. Your body stayed here, warm and still, the whole time we were out there, but part of you did travel. Some corner of your mind went out to Mercury and felt the contrast of heat and cold. Some part of you floated in Venus's amber clouds. Some part of you stood on the rust-colored plains of Mars and heard the silence. Some part of you drifted through the asteroid belt and swam in Saturn's rings and felt the blue of Neptune settle over you like a cool cloth. That part of you is back now, and it is carrying the quiet of those places with it, the enormous, enduring, patient quiet of the solar system. Let that quiet stay with you. Let it press gently down on your shoulders, on your chest, on your eyelids, the weight of a whole solar system's worth of silence, held lightly, like the softest blanket. Your breathing is slow and easy. Your heartbeat is steady and unhurried. The bed beneath you is solid. The air in the room is warm enough. There is nothing that needs to happen in the next few hours. Nothing that will not wait until morning. The solar system is out there in the dark, doing what it always does. Turning, orbiting, slow and steady and reliable. The sun will rise again in the morning. It always does. It has risen every morning for 4.5 billion years, and it will not stop on your account. You are safe to rest. You are allowed to sleep. The universe has this covered while you are away. Tonight we traveled across the vacuum and through the gas clouds and over the ice fields and past the storms and beside the rings and into the cold and the dark and the blue. We visited 8 planets and their many moons. We stood at the edge of the solar system and looked back at the little bright dot that is our sun and understood, for a moment, how extraordinary it is that this particular dot has this particular family of worlds, and one of those worlds has us on it. We followed the path the sun's gravity draws through space, and we felt how patient that gravity is, how it never stops working, how it holds billions of objects in their orbits without effort, without fatigue, without needing anything in return. It is simply what gravity does, and what you need to do right now is simply what sleep does. Restore, renew, make you ready for another day on the most extraordinary planet in the solar system. If you enjoyed this journey tonight, I hope you will come back. There are other evenings like this one waiting for you here, other slow travels through places that deserve quiet attention. You can find them by subscribing to this channel. And if this helped you rest, if it gave you even a few minutes of peace you might not have found otherwise, then please consider leaving a like or sharing it with someone who could use a quiet night. It costs nothing, and it means everything to this kind of work. Thank you for traveling with me tonight. Thank you for your patience and your willingness to simply float for a while. That is a rare and beautiful thing. Now let your eyes stay closed. Let your thoughts drift where they will. Let the solar system keep turning out there in the dark while you rest here in the warm. The planets are patient. The stars are patient. And sleep is patient too. It is already here. It has been here for a while, waiting quietly at the edge of your awareness. You do not need to invite it. You do not need to try. You simply need to stop moving, and it will do the rest. So stop moving. Let everything go still. Let the breath slow to its own natural rhythm. Let the last thoughts of the day drift past like slow comets crossing the inner solar system. You don't need to catch them. Let them go. Sleep well, and good night.